We are going to explain today on some of the case studies and how using twin screw and twin screw helps on retaining mechanical property, thermal property, WPC, and many composites because natural fibers are very sensitive to shear. When you are going for a twin screw, it has to distribute and disperse and get the elongation flow. And the outline, what I was going to discuss today is a modern technology of twin screw extrusion. Currently, we are at the 20th century and 21st. I will discuss both 20th century and what are the drawbacks and what are the improvements and how to overcome of the 20th century to get the required property of WPC in 21st century. And these are the case studies. I have a lot of case studies, polypropylene wood composite, and now there's a trend was happening for a biodegradable polymer, PBAT PLA with a wood composite, so that it is 100% biodegradable. And PBAT lignin, this is also 100% biodegradable. And rest of the things, polypropylene jute rovings, polypropylene bamboo fiber, using polypropylene hemp. There are many list are more, and we have used our twin screw extruder to process. What is the purpose, what why we are here? And Steer is a creator of advanced material platform technology that effectively transfer and functionalize the material into the field of plastics, pharmaceuticals, food, and biomaterials and the biorefineries. The steer serve in the industry, in our technology. First, we have talks about polymers. In the polymers, we talks about engineering polymers and polypropylene compounds and WPC compounds using polymers. And also, we serve the industry in the term of biomaterials like PBAT, TPS, starch combination with the wood composite and lignin composite, and also provide powder coating technology construction for the continuous line so that can utilize for a uh, building applications, and also for the humans like a pharmaceutical applications like hot melt extrusion and food technology like fortified rice and many others. We have four application development center, one situated in Pinya industrial area. There's the left hand side. The first slide photo, what you can see in Pinya industrial area, Bangalore. We have four extruder to support the customer and help the customer to improve the mechanical property in the WPC and also jute composites. Second one is we have USA, and if any customer approach in USA, we have application development to support and process in the pilot scale. We have two extruder over there, and Japan, and also similarly same activity happens in China also. Now we are talking about the modern technology, and also there is a 21st century. 21st century technology, it's last 30-40 years. We have a twin screw, a high screw speed and higher torque capability, handling capability, larger drive, and greater throughput, but and also lesser residence time. But we could not able to utilize the complete extrusion because of the fear of these feeding limitation. Like when you are going for a wood composite or many low bulk density material, difficult to feed into the extrusion. Second thing, we have a peak shear, what we call it is a peak shear that degrades the wood composites and also natural fibers. To overcome this, and also higher temperature, to overcome this, we have a solution as fractional geometry technology. Because still in the industry, many operator had a bigger extruder, but they could not able to get the required throughput, and there's still fear there should be any degradation on the polymers, because that we call it as a peak shear. What is peak shear? The mechanism of peak shear, because many of them you are already seen twin screw. In the twin screw is a segmented screw, Again, we are talking about the Bilob technology. Bilob technology, the standard technology. These are profiles or screws is created by Adminger, okay, as a German scientist, lost 40 years back. But there is no much change in the industry. There are many industry using standard technology. They have right hand kneading block, neutral kneading block, 90-degree, and left hand kneading block. These two, most of the time, create peak shear. If you see the first picture, the screw starts rotating. If you have full melted material in the first screw, when the screw starts rotating between the gap, screw gap between the, we call it as a narrow gap, the small amount of melt trapped in the last screw, the screw starts rotating slowly and it trapped hardly 3 to 2% of molten melt trapped there. And every rotation, that because of the peak shear, it degrades the polymer and also increases the melt temperature, that leads to the degradation of the polymer. The down, if you see that is called peak shear. The input material is in white color. Finally, after compounding, you are getting the degraded polymer in the metering section. The degradation cannot occur in the many shear sensitive materials like PVC, and also sensitive material like wood composites, like bamboo, and many other, like even for a biodegradable polymer like a PBAT and PLA, very sensitive to shear. It degrades and liberates the black specks, and that no use at all. Once you compound it like a degraded polymer, then you cannot use a product out of that. Now we are talking about the modern 21st technology. This is 21st technology, modern 21st technology. We call it as a fractional geometry technology. Fractional geometry technology had narrow, constant clearance, and low temperature on the melt temperature of the polymer, higher output. You can utilize your extrusion up to 1200 rpm. There is no degradation on the polymer, and higher output, self wiping. It cleans by screw to screw. It wipes the polymer and go to the next level. There is no stagnation. Wipe Self wiping means there is no stagnation of the polymer on the screws. And we had DO by DI 1.55 and 1.71 deeper flight groove, and it was a controlled shear throughout the system. There is no degradation polymer. There is a continuity on the peak shear. That leads to higher RPM and higher output. This is a difference between Bilob technology. At the top, you have Bilob technology and fractional geometry technology. If the Bilob technology, I have already explained about the peak shear. The peak shear, this melt trapped in the narrow gap and degrades the polymer. But in the case of fractional geometry technology, it maintains the melt and there is no degradation, no peak shear. If you see the when the screw starts rotating, it had a full melt, okay, full melt inside the between the screw to screw. There is not much degradation. It is a uniform shear. But when if you feed the screw, it was taken the picture from the extrusion. We see input material is a white and the output is also white. There is no degradation, no yellow coloration in the fractional geometry technology. The fractional geometry technology we're talking about, these are the fractional geometry technology. It's a trilobe in nature, and it had enhanced the uniform melting and mixing when compared to the standard screw kneading. It is capable of stretching because it stretch the polymer and fold and squeeze, and also in the tight control kneading, that particular cycle, it gives a distribution of the polymer and with the wood composite, and also reduce the melt temperature. Now, we are talking about one the case studies on the natural fiber and floor composites. You know already the what are natural fibers. I'll give just classification what natural fibers. Starts with natural fiber, we have left hand side natural fibers and synthetic fiber. Synthetic fibers are organic like aromatic and also polyester, and there are inorganic glass fiber, carbon fiber, bond. This is already in the industry, but it is not biodegradable, and many automotive industries already using composites of glass and carbon fiber. When it comes to the left hand side natural fibers, there is a animal, plants, minerals. Okay, when it comes to the animals, your horn powder, and recently we have, did one of our big customer is using horn powder to making the buttons out of that, and we supplied extruder and horn powder with polypropylene, also polyester. And we did chicken feather compounding with the polypropylene, and to make like many other articles like pots and garden pots and many things that leads to animal. And the plants you can talk about, it's a huge list like jute, wood powder, there are many things. And again, recently we are talking about this jute stem. Jute stem, many people are when it is left out and they are going to bury. But recently we are utilizing jute stem, the unused, it is a waste going to that, and we rework on that, adding into the polymer, and now the stem is also making into powder form and getting better mechanical property compared to the jute fibers. Even we are utilizing jute stem, and also when they crush from the mill, that jute powder, the left out jute powder also utilizing, and we are able to make some products out of that. And bamboo, wood powders and seeds, these are the things. And when it comes to the mineral filler, you can say mica, calcite, these are the mineral fillers. Main producer of natural fibers, maybe it's a old slide, looks like a recent slide I didn't get, that's why I put it. Major is in India, jute, Bangladesh and India, cotton, you know, that USA. There is a list, I will not go in details. I think it is available in the website and Google. Why we need a natural fiber? Natural fiber, it's a bio based. At least if you add a synthetic polymer with the wood powder, at least 50% is a biodegradable. If you use a biodegradable polymer with the natural fiber, it's 100% biodegradable, so that it's eco friendly, and it's biodegradable and readily available, and also lower in cost, eco-friendly, and you can minimize the waste. That's the reason. And also lightweight. If you are going for automotive industry, it's a lightweight, replacing some of the where you need outside peripheral, outside in the some of the products needs not at the engine, but when outside the sheet and all, you can utilize for the natural fibers for a replacement. In automotive, sheet metals, they you can replace, and you need plastic composites, and effective is the reduction of weight to easy to disposal. What are importance when you are going for a natural composite? It's a basic reinforcement, natural fibers or floors. To anyway, it's a hydrophilic, and to there are problems bonding, do that you need to have some of the bonding agent to mix together, so that you can make a better composites. uh, I have just names some of them: polypropylene, polyethylene, HDP, ABS, PS, and PLA. There are many. Okay. The first case studies we are going to talk about the wood powder. What are the advantages of WPC? First advantage, it can be almost any shape can be utilized. When you do the compound with the polypropylene with the wood powder, depending on your requirement, the shape can be molded and also compounded in the twin screw. And also, depending on your wish, color can be changed. That's one more advantage. And the wood composite is a moisture resistance, because if you know that wood powders are hygroscopic in nature. If you keep it for a longer period of time, it absorbs moisture and starts swelling. But when you add a polymer composite and do make the compounding, then it is a moisture resistance. It keep for, even if you put it in the environment, keep for a longer period of time. There is not much wear and tear. If you put the wood sheet directly on the floors, if you are keep on, okay, going every day, there is a wear and tear. But if you use a polymer composite, there is less wear and tear onto the final product, and it stay longer. And heat resistance, if the flame retardant can be introduced into the WPC, so that it can be made on the flame resistance, like FR can be added to make the door panels, your door panel should be flame resistance. And it can be utilized for a building construction and manufacturing, many things can be done.